Hello, everybody. Hey, we're going to do a quick lecture on what is called the range formula and maximum height formula, and this is directly related to two-dimensional motion. And when something is going to be launched up into the air, as you already figured out, it's going to be a parabolic curve. But if it goes up and comes down at the same level, the following two formulas are going to come into play and be useful. And again, the key here is we're ignoring air resistance, and it's going to be on level ground. Okay, and I'm going to be talking to them, so you guys can just listen along. All right, so we already, as we talked earlier, okay, if we throw something up, it's going to form this parabolic curve. We also know that the velocity in the x direction is going to be constant. Okay, there's going to be no acceleration. Okay, and we know that the velocity in the y direction at the top is equal to 0. And we know that acceleration is equal to g, which is going to be negative 9.8 meters per second squared. And again, we talked about this earlier in the week on Monday, week 1 lecture, or week 3 lecture 1, when we talked about the moving in 2 dimensions. So the key here is kind of the time, okay? And so the first thing we're going to talk about and try to figure out is what is our maximum height? What is our maximum height? So we know our maximum height, our V final, is going to equal to 0. But this is going to kind of change somewhat depending on the angle, okay? Because if we throw it at an angle that's essentially greater, okay, it's going to go higher, okay, than if we throw it at a lower angle. And we can obviously see that because we're going to get different parabolic curves, and that height is going to change. Okay, so we know that delta y is equal to VIT, and this is going to be the initial velocity in just the y direction, okay, minus 1/2 gt squared. We can also have v final y is equal to v initial y minus gt. And we could do the other one. So now this is perhaps not as clear, but remember, if we have an initial velocity at a certain angle, okay, then we can break this into two components. We can break it into the initial velocity in the x direction, and we can break it into the initial velocity in the y direction. Okay, and how would we get, okay, if we knew our initial velocity, the hypotenuse, and we knew the angle, how do we get that side?
We need to like the trigonometry. I don't think of the right equation, but yeah, sine and cosine.
Okay, so that the initial velocity in the y is on the opposite side, so VI sine theta is going to equal to VIY. Got that, Mackenzie? Sorry. And so now we know that this is going to be 0, okay? And we now know that this VIY is going to equal to VI sine theta minus GT, and therefore VI sine theta divided by G is equal to T. Okay? So this equation right here, that equation right there is going to equal to the time to the highest point. Okay, so that is the time to the highest point.
Because you use the y from the
Right, because remember, that's
yeah.
going to go up
Yeah.
and come down independently of the x direction. Okay, so if I throw something up, let's say at 4 meters per second, and I also shoot something up, let's say at 5 meters per second, but at an angle of 53 degrees, okay, then they're going to go up and come down at the same time, because if I go up at 4 meters per second, or I go 5 at an angle of 53 degrees. Now remember, if we do 5 sine 53, that's equal to 4 meters per second. Okay, so their initial velocities are going to be the same going up, and so it's going to be up in the air the same amount of time. Now, obviously, this one is not going to go as far, but this one is going to go at 3 meters per second, 5 cosine 53. So however long it's in the air, if we want to calculate the distance, we would just do that. So what if we multiplied 2 by that?
It would be the total.
That'd be the total time in the air, okay? So 2 VI sine theta over G is equal to time total. All right, so we want to know how high it's going to go. We want to know how high it's going to go. Okay, so this right here is going to be H max. So that delta Y is going to be H max. Okay, delta Y is equal to H max, which is going to equal to VI. That's equal to VI sine theta, right? Okay, because VI sine theta is VIY. Okay, and now we're going to say minus 1/2 G, which is going to be 9.8 on the surface of the Earth, okay, times T, times this T, which is going to be VI sine theta over G. This whole quantity gets squared. That whole quantity gets squared.
Because that's the entire time.
Because no, this is still half the time.
Well, I mean, it's the entire value of time for that.
Correct. Yeah, this is the entire, because we have a t squared. So this is still just the time to the top, because we're looking for maximum height. All right. So VI sine theta minus 1/2 G VI squared sine theta squared over G squared. And now this G right here is going to cancel out with one of those. And we're going to get H max here. And if we say that this is VI sine VI sine times VI sine theta.
You can like divide it all out of the. You can take like a VI sine theta and like what's it called? Like take it out.
We can factor out.
Yeah.
So that is going to be. I'm not sure that helps us though.
When is the equation done? Like what's the
Oh.
What are you trying to get it to like simplify it to?
I'm having a little brain fart here. So if we want,
it should be 2G.
we had this is G squared. It canceled out there. Sorry guys, I'm blanking here.
Are you trying to simplify it further, or?
I forgot something.
Oh.
I left that off, right?
Yeah.
Now this is gonna make this a lot easier. Okay, so now we're gonna have VI sine theta times VI sine theta over G. Okay, and that's not squared, and that's going to be minus. So we're going to have VI sine theta times VI sine theta. VI sine theta times VI sine theta, all divided by G, but notice that this is essentially a half. And we are going to have a whole minus a half. We have a whole minus a half. And therefore, it's going to be a half. So when we subtract this, this is going to be VI sine theta squared divided by G. And this
shouldn't be divided by 2G, or 3.5.
And thank you. And it should be divided by 2. So this right here, that right there is our equation. That is our equation for maximum height. Maximum height. Now, really, that right there would give you the maximum height above the launch point, right? So this is not necessarily have to be on level ground because it's not there. It's not there at the top. Okay, so what we can do now here is talk about how far it goes. All right, we're going to talk about how far it goes. Okay, and now what we're going to do is say delta x is equal to vi x t plus or minus 1/2 a t squared. But remember that goes away because there is no acceleration. There is no acceleration in that distance. And this right here this is the range, or x max is going to equal to Vix times time. Now, in the same way that if this is Vi sine theta, then this is going to be Vi cosine theta. So our initial velocity is Vi cosine theta. And our time is going to be, now remember, our time to get to the top is Vi sine theta over g, but as long as it's level ground, okay, the total time is going to be 2 Vi sine theta over g. So now we're going to plug in this 2 Vi sine theta over g. Okay, so this in turn is going to be Vi squared, because we're going to have a Vi times a Vi, which is going to be a Vi squared. And then we're going to have 2 cosine theta sine theta divided by g.
Aren't they different? Oh no.
Same angle, okay, but one's sine and one's cosine. Okay, now, do you guys recognize this being able to be simplified?
Yes, I don't remember what
you guys, that is a trig identity. That is a trig identity that's equal to sine 2 theta. Sine 2 theta, okay? So what we can see here is our range is going to equal to Vi squared sine 2 theta over g. All right, makes sense? Now, you guys, these become kind of interesting here. And we've got our 4 equations here. What I'm going to do is go over an example. I'm going to go over an example here, and that will probably take us till the to the end of the period. So I'm going to erase this stuff up here, and then we're going to use these equations, and we're going to see how easy it is. Okay. All right. So let's say we're going to launch a projectile. Let's say it's going to go 20 meters per second at an angle of 60 degrees. Okay, 20 meters per second at an angle of 60 degrees. So my question is, what is our maximum height? What is our maximum height? Okay, now we're going to plug into this equation Vi squared sine theta squared divided by 2g. Now, because we have this formula, we do not have to take the 20 and do cosine 60 and 20 sine 60, okay? It's right there. So we're going to say 20 squared times the sine of 60, oops, that whole thing squared, divided by, in our case, 19.6, which is 2 times 9.8. Okay, what is the value for the sine of 60?
It's square root of 3 over 2.
And what is, so if we say the square root of 3 over 2,
Squared.
okay, but that is squared, so you get the number. Now in your calculator, they're going to give you a decimal, which is going to be like 0.866 or something, okay? And then you're going to square that, okay? So the square root of 3 is going to be 9, and 9 divided by 4.
Square root of 3 squared is
3. Right, exactly.
Yeah,
So it's going to end up being 3/4, right? So, so now we're going to say 400 times 3/4 divided by 19.6. So 400 divided by 4 is 100. 100 divided by, 100 times 3 is 300. 300 divided by 20, okay, that's about 20. So that's about 150 meters high, right? Did I do that right?
15.
300, 15 meters.
Yeah. 15
meters. Okay, so since we're not dividing quite by 20, it's going to be a little bit higher than that. Sam, did you get something?
15.3.
15.3. Okay, so our H max is equal to 15.3 meters. Okay, so that makes it pretty easy. Okay, and now let's just come in here and we'll do this equation right here. And now we're going to say VI squared, so that's going to be 20 squared times the sine of 60. Okay, but what is 2 times 60? What's 2 times 60? Okay, well 2 times 60 is 120, right? So we're going to take the sine of 120. The sine of 120. And now we're going to divide it by 9.8. Okay? And if we think here, we've got 60 here, and we've got 120 here, so 60. So what is the sine? What is the sine of 120? Okay. Remember, it's still going to be the square root. It's still going to be positive, and it's going to be the square root of 3 over 2.
Yeah.
It's going to be the square root of 3 over 2. And so now we're going to have 400, okay, times radical 3 over 2 divided by 9.8. Okay. So radical 3 is about 1.73 divided by 2 is about 0.87. 0.87 times 400 is going to be probably about 3,500, and then we divide it by 10. So we're talking probably 350. So we're talking about 35 meters-ish. Okay. So if you guys do the math there, what do you get?
35.35.
35.35. Okay. So our range here would be 35 meters. Okay. And I didn't really pay too much attention here to significant digits, okay? But that makes those kind of problems pretty easy. Okay, makes sense? All right.
They can also like work backwards.